We are working on Thevenin and Norton circuit. So let's work on the problem 5.3.9. So we are asked to find the Thevenin and the Norton circuit. The first one, let's find the VTH. And this is our load because we are asked to find the V0. And then we need to take this off. That means we're going to have this circuit. How? Any suggestions? Any observations? Anything? Oh, here, call it V1. Okay. This is very specific case. If it was in the middle, we take it out and you do KCL, KVL. However, we took it out, V0 is assigned in here. And then also this dependent current or voltage source is dependent on this V0. We took it out. So now when you look at this, there's no information about the V0. There's no V0. So we need to do something about it. What's the V0 in this circuit? Exactly. This is the VTH. So when you do this, V0 is anymore. The V0 place, now we have a VTH. So we need to change this as a VTH. This 12 volts. It's really 12 volts in this circuit? Not anymore. Why? It's open circuit. And since we have a one loop, I want to find the V1 using voltage division because this side is a nothing. Yeah. Hold on. I'm not going to get rid of it. We are not considering this guy at this point because it's an open circuit. Therefore, simply we can do the voltage division because now we are having only single loop in here. That's what I'm saying. Because this is the open circuit. No current go through there. So now, since this is the single loop, I'm going to do the voltage division. So here's the V1. We want to find the V1. And the voltage division series of resistor and the voltage source. So 2K over 1K plus 2K, and the voltage source 1 over 2 VTH. So that is 2 over 3 times 1 over 3 VTH, which is 1 over 3 VTH. Then, just like what we did before, since this is still open circuit, we can do KVL. KVL in the second loop. We can do that now. We found this guy. KVL using blue one. We have negative V1, negative 12, plus VTH equals to 0. And the negative V1, negative 1 over 3 VTH plus VTH equals to 12. 2 over 3 VTH equals to 12. VTH equals 12 times 3 over 2. That is 18 volts. Yeah. Since we have an open circuit, this 12 volts is nothing to do with this side of the circuit. That way we can do the voltage division, ignoring this portion. If this is closed one, then we cannot do the voltage division. This is not the only voltage source distributing here and here, if this is closed. But since this is open, we don't have to worry about this 12 volts. Okay? This is open circuit, nothing going on. So that's how we can do this voltage division in this side. Yeah, well, it looks like that, but it's not. Because when you deal with the VTH, we had the component in here and we took it out. So somehow we need to consider there is a voltage across here. So when we analyze this, finding V1 in this case, forget about this guy because there's no current going there. However, finding VTH, we need to keep it and we need to analyze with other components. I'm going to say that again. When you take this load out, we end up getting this circuit. Since there is no current going there, VTH is parallel to V1. No, it's not, because when we calculate this VTH, we have to consider negative 12 volts from the original circuit right there. So it's not. Only thing we can say, since we took it out as make it as an open circuit, there's only one loop. Therefore, we can do the voltage division to find this relationship between V1 and VTH. And then actual calculation finding VTH, we need to reconsider this voltage source by doing KVL. We have VTH, right? VTH equals 18 volts. Now we need to find RTH, right, for the Thevenin. How you find the RTH? Finding RTH, we need to let this guy as a short circuit, as a independent voltage source for the short circuit, independent current source for open circuit. However, we have a problem because this is not independent source. This is the dependent. Therefore, we cannot turn it off. If that is the case, we're going to make it short circuit, finding I sub n. That's how you find the Norton circuit in your homework. You're going to take it out. It doesn't matter if you have an independent, dependent. You need to take it out, the load, and then make a short circuit. And you're going to name it as I sub n going downward, finding that I sub n. That'll give us the Norton circuit. Any suggestions? Oh, that should be V naught, not VTH. Good point. So now, and then where is a V naught? This should be the circuit. We took it out 1 kilo ohm. That's the V naught. We took it out, make a short circuit. Still, this dependent voltage source is dependent on V naught. Where was it? In here. Yeah. Node analysis. Okay. And node A. Any other observation? Yeah, we can do mesh. We can do nodal. But before we get into that, what do we do with this guy? So when you find the VTH, because we make it open circuit and call it as a VTH, we change this to VTH. Now it was a V naught, we put it back to original. And now we need to make a short circuit. What's the value of V naught? 0. Then what's going to happen to this guy? Exactly. Right. Norton and Thevenin problem. You will be given the finding V naught or I sub 0. I can ask you to do find I sub 0. Still, you need to do exactly the same procedure to find VTH. Take it out, put the VTH. Once you find the voltage across this guy, that divided by this will give us I naught. So you'll be always asked voltage or current go through any given resistor. So that's the thing we need to take it out. Since this is the V naught, we need to take it out. And the Norton circuit, we have to make it a short circuit, always. And then the direction of current going downward, and we're going to name it I sub n. Always, no exception. If this is V sub 0, and if you want to take this out, that means we're going to make this as a short circuit, I sub n, always going left to the right. Okay? And then we've figured it out. So that's what we want to do. So now what? Okay, and that is 1 times 2 over 1 plus 2. It is 2 over 3K. So now we have a 1 loop. What's the actual current direction? Which one? 1 or 2? Higher to low potential. So always confusing. Yeah, of course. As current is just like a water, higher to lower, right? Higher potential to lower potential. 1 or 2. You remember the only simple circuit that I drew all the time? If you have this circuit from the first day or second day of the lecture, what's the direction of the current we go all the time? It was 1. So this higher potential to lower potential, when we assign the polarity for this guy, we're going to call it V1, higher potential to lower. Exactly opposite to this. That's why I keep telling you, you need to understand this single loop. Otherwise, it's going to be really confused. You have to think about KVL. KVL, negative 12, positive 12 equals to 0. This guy has to be positive. When I say higher potential to lower potential, it's not this voltage source. That's not applicable to this voltage source. That's applicable to all the resistors. Higher potential to lower potential. To the KVL, what's going to happen? This is the negative 12. So we need to have a positive 12. So since this is the correct, I sub n is the positive. What's the I sub n? V over R. Now we have IN equals to 18 milliamp. The question is, how did that happen? I don't know. It's just coincidence because of all of these values that happen to be that. So now Thevenin circuit is going to be plus minus VTH. And then RTH, which is VTH over IN. We said VTH as 18 volts, 18 milliamp, 1 kilo ohm. And what did we took it out? 1 kilo, and that is V naught. So this is 1K, this is 1K. VTH is what? 18 volt. So V out is going to be just 9 volts. And then Norton is going to be go I sub n RTH, which is 1 kilo, and IN equals to 118 milliamp. And since this is 1K, this is 1K, I sub 0 equals to 9 milliamp. Therefore, V sub 0 is 9 milli times 1K, which is 9 volts, which is exactly the same. Watch here. The question is, why both? Right, we can just find the one Thevenin only. We can find the Norton only. However, since we have dependent voltage source, we have to find I sub n in order to find RTH. There's no other way to find RTH. Since we have a VTH, IN, RTH, we can simply build the Thevenin and Norton circuit together, and you can check the answer. But I may ask you to Norton only, then you find this guy, RTH, and show this Norton circuit and find the V naught. If I ask you to find VTH, you need to find VTH IN still because of the RTH, and V8 VTH over IN, you find the RTH, show this, find this, done. Oh, this is 18, so simply voltage division. I didn't write the equation because this is 1K, this is 1K. They're the same resistance, so has to be 9 volts, 9 volts, 9 volts, 9 volts, right? And you can use the voltage division, or you can find the I sub 0, 18 over 2K, which is 9 milliamp. So different ways to look into it. Now, can we do it without VTH IN? Yeah. How? So forget about VTH, RTH. So let's use simple one. KCL. You like KCL? KCL where? Here. Gonna call it V1. Current going in that direction down. KCL at V1. So basically you're saying nodal analysis. The nodal analysis, this is 1 over 2 V naught. And this is V naught. And we need to do supernode. So KCL at supernode entering 1 over 2 V naught minus V1 over 1K equals leaving V1 over 2K plus V out over 1K. And we do KVL with supernode. That is negative V1. Be careful, this is the negative V1. Negative V1 minus 12 plus V naught equals to 0. Now, it is the two equations and two unknown. We have V naught minus V1 equals to 12, one equation. And this equation, we multiply everywhere by 2. So 2 V naught minus 2 V1 equals V1 plus 2V2 V naught. I'm going to move this guys over 3V1, move it over 3V naught. No, negative V naught. V1 equals negative 1 over 3V naught. Plug it in here. V naught minus 1 over 3V naught equals to 12. 4 over 3V naught equals to 12. V naught equals to 12 times 3 over 4. Okay, it's much easier. However, if I ask you to find Thevenin and Norton, then you have to go through that. But always, you can check your answer doing nodal analysis or mesh analysis.